Here is the code. This is from the Liang Release 10 textbook. We have a method named Insertion Sort that expects input of an array of integers. It's going to refer to that array as list. As soon as our method begins, we start a for loop controlled by an integer named I. We set it to an initial value of 1. And while I is less than the length of our list that was passed to us, we'll increment I. We will declare an integer named current element, an integer named k, and go into an inner loop. In our inner loop, we'll set k equal to 1 less than I. We'll execute this loop while k is greater than or equal to 0 and the element value in our list at position k is greater than the saved element or current element. As we execute this for loop, we'll be decrementing k. Within our for loop, we have found a position where our array is out of order, so we will set the item at position k into the item at position k plus 1. So we'll move that item 1 down in our array. As we continue executing our k loop, we'll decrement, again checking our condition. When we complete our k loop, we will set the empty position that we used basically to move into 1 position higher, and we will set that to our current element so that those array entries will be in order. We have a main here that sets up an array with some static values, some compile time array values. Then it calls the insertion sort using this list of values. Now when it's done, it does a for loop to print everything out. So you're going to need some supplies to do this with me, and I hope you will, because if you just watch along, it's really not going to mean as much to you. If you get some supplies out and kind of step through this process with us, I think it'll be worth your time. It has been to the people that were in class. I need you to have a couple sheets of paper, probably side by side, some small post-it notes, a pencil or a pen, and your thinking cap. Draw some squares across the bottom of the pieces of paper, each of them large enough to hold a post-it note, and we're going to place a blank post-it note in each. So something like this. Now leave a little bit of room at the bottom, because across the bottom we're going to write index values for our array. So this is index position 0, 1, 2, etc. Grab another post-it note and label it I, and one more that's going to be K, and we're going to move these post-it notes around underneath our array to show the position of our index pointer. So this is our basic layout. We're ready to do some sorting. Here is our main code. We're going to set up all of these numbers from our array into our array post-it notes. So we're ready. We'll need to keep track of 3 more variables through this sort besides our array elements, so write them down so that you can accurately follow the code. We need I, K, and our current element variable. As we begin the loop, initialize I. Write the value down by your variable name. Move your I post-it note to the correct location. I is now pointing to the array entry with the value of 9 in an index position of 1. Note that the length of our list is 6, so in our code, our for loop will execute. Next, we're going to execute the line of code that allocates the item in position list sub I into our current element variable. Now we've got k, and we're going to go into our inner loop. So we're going to start out with k set to I minus 1. We need to evaluate the loop condition for our inner k loop. Is k greater than or equal to 0? Yes, it is. Is the value at list position k greater than our current element? The value at list position k is 1, and our current element is 9. So no, it's not greater. Now, because of that, we'll fall through and not execute our for loop, and we'll continue executing our outer loop, our I loop, and we'll get to the line of the code that says to set current element, and we want to use current element and use it to set the value of our list position at k plus 1. Our list position at k plus 1 is 9, and our current element is 9, so there will be no net change. So the first iteration is complete of our I variable, our outer loop. There was no change to our array, none at all. The first and second positions of our array were already in the proper order. So now we're going to update the value of I, check our condition of our outer loop, and iterate again. Update the value of I will move us to 2, and I is still less than the length of our list, so we will execute our I loop. We'll get to the line of code that says to update our current element variable. We'll do that. Then we're going to begin our inner loop setup, and we want to set k equal to I minus 1. So k is following along behind I. Evaluate that inner loop condition. Is k greater than or equal to 0? Yes, it is. Is the item at our list position k greater than our current element? Our list position k is 9 and our current element is 4, so yes. So we're going to execute our inner for loop. In our inner for loop, we're going to update the value at k plus 1 and make it the value of k. So we're basically going to move our 9 over to take the position there, because they weren't in order. So we've moved our 9 over. It needed to bump over. So in our inner loop, we located that misplaced item. We moved the misplaced or larger item to replace the smaller item. With our post-it note scenario, our array cell at position k is now empty. In reality, it would still contain the value 9. I will update to show that, but you need not be concerned as you follow with the sort. Now we're going to execute the update phase of the inner for loop by reducing the value of k by 1. Evaluate the condition again of our inner loop. Is k greater than or equal to 0? Yes, it is. Is the item at list position k greater than our current element? No, it is not. So we will not execute our inner loop again. We will continue executing our outer for loop by updating the data at list position k plus 1 with our current element. Now another execution of our outer loop. We're going to be looking at updating I, and it is still less than our list length, so move on. We're going to update our current element variable by using the data from our list at position I. Notice I'm kind of skipping over the line of code that declares the integer named k, but we do have to do that outside of our for loop because we're referring to that variable on the other side of the for loop. So when we get to our for loop, our inner for loop, we're going to set k to I minus 1 as an initial value. Then we're going to evaluate our condition. Is k greater than or equal to 0? Yes, it is. Is the item at list in position k greater than our current element? Yes, it is. So we're going to execute that inner for loop. In our inner for loop, we're going to update the data at list position k plus 1 with the data at list position k. We found that that 9 was larger, so it belongs over where that 6 was. Now, we want to execute our inner loop condition, or update, again, by decrementing k. So we'll move it over there a little bit. Evaluate our condition again. Is k greater than or equal to 0? Yes, it is. Is the data at list position k greater than our current element? No, it's not. So we will not execute our inner loop again. We'll fall through and update the data at k plus 1 in our list array with our saved current element. Now, we're going to return to the outer loop to update the value of I and reevaluate our condition. Notice that all of the values less than I are sorted. Make sure all of your notes are up to date and that everything is working, and you're moving your post-it notes around, and I hope you're seeing the patterns here as we execute our algorithm to sort this data using this sort. Now, I'm at the point where I'm going to update the value of I. We're at our outer for loop here. So we'll see that we're going to update that to 4. It's still less than the length of our list, so we'll continue executing our outer for loop. We'll update the current element variable with the data at this position in our list. Then we're going to begin our inner loop by initializing k to I minus 1. And we're going to evaluate our condition here. Is k greater than or equal to 0? Yes, it is. Is the data at list position k greater than our current element? Yes, it is. So we're going to execute that inner loop and set list position k plus 1 equal to list position k. Now we want to execute the update portion of our inner loop by decrementing k. As we continue with our loop, we're going to evaluate our condition. K is greater than or equal to 0. Now, is the data at our list position k greater than the data that we've saved as our current element? Yes, it is. So we're going to execute our inner loop again. And we'll set the variable at list position k plus 1 equal to this data at list position k. Now we'll decrement k again. Evaluate our condition. Is the data at list position k greater than our current element? No, it's not. So we'll fall through to our outer loop and update the information at list position k plus 1 with the data we had saved as our current element. As we prepare to increment I, notice that we'll be at the tail end of the array. The value -4 will be pushed all the way to the head of the beginning of the array. So in our for loop, we're going to increment I it's still less than the length of our array, so we'll execute. We're going to update the data in current element to be equal to the data at this position of I. We're going to go into our k loop, our inner loop, and initialize k to begin at I minus 1. We're going to evaluate our condition. K is greater than or equal to 0, yes. Is the data at this position k greater than our current element? Yes, it is. So we'll execute our inner loop. We'll update the data in position k plus 1 with the data at position k. We'll return to our for loop and decrement our k index. Evaluate the condition and see that yes, the data at this position is greater than the current element we had saved. So we will update and move this data from position k to k plus 1. And of course it would remain in position k in reality. Now we're going to update k by subtracting from it again. Our condition, is the data at this position greater than our saved value? Yes, it is. So we'll move it over 1. We'll decrease the value of k. We'll do the comparison and see that yes, the data at this location in the array is greater than our saved data. Execute our inner loop, which will adjust the position of this data to one position further in the array. We'll decrement k again. We'll check our data and see that yes, it is greater than the data we had saved. So we'll execute our loop and move this data over one position. Now we'll decrement k, and that's going to end our inner loop because we're going to go less than 0. So continue on with our outer loop and update the data at position k plus 1 with our current element. And if we increment I one last time, we'll exceed the length of our array. So we'll end our outer loop and we'll have a sorted array. I hope this helped you. Thanks.